Here's 2013 question 2. From what I see here, this is a particle motion problem, okay? It talks about a particle moving down a straight line. Here they give you the velocity of the particle, and then they give you some fact that at 0, the position is at 10, okay? So we'll come back to that part in a second. Here we go. Part A. Find all values of t from 2 to 4 for which the speed of the particle is 2. So, two things here. We need to know where the speed comes out to 2. You guys have to remember that speed is the absolute value of velocity, okay? So, what I would do here is I would program y1 as your v of t. So, write out -2 plus t squared plus 3t quantity to the 6/5 power minus t cubed. And then what you would do is I would go to y2 and type out the absolute value of v of t. Okay, the absolute value is actually, if you press math, toggle to the right, and it should be the very first one that says ABS. Okay, if you type that out, it should come out 2 vertical bars, and you're just going to do the absolute value of y1. Remember, to get to y1 is just alpha trace. So what you would do here is, now y2 is going to represent speed. This is your speed right here. And you guys want to see where speed is 2. So what I would do is I would graph a y3, and I would call that 2. Okay? So the only thing I would graph right now is y2 and y3. Notice how you're only looking in between the intervals of 2 and 4. So when you guys go to your window, your x min should be 2 and your x max should be 4. Okay? You may or may not see an intersection based on how high or low this graph is going to go. We're just going to graph it and see what happens here, okay? If you graph it and you see the intersection, calculate it by going to second trace 5, and then picking the first curve, second curve, and to guess. In this case, you could just press enter, 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 because there's only 2 functions available, okay? Now, I don't have the graphing function in front of me, but if you graph it and you don't see it, you might have to extend your y min and your y max out a little bit more, okay? So just keep that in mind. So if you see the intersection, it should come out to 2 different values. You're going to have to intersect twice, so you're going to have to calculate it twice. Guessing actually does matter in this case when there's 2 intersections, so your guesses have to be close to the one that you're interested in, so just keep that in mind too, okay? But that's pretty much it for part A. Here's part B. Write an expression that involves an integral that gives the position of s of t. So that's just the first part there. Use this expression to find the position of the particle at time t equals 5. So they're asking us for 2 different things. So here's how I would approach it. They want me to find position, so I know I have to integrate v. Okay, I need to integrate v. So the question here is from where to where. So remember, I want to go all the way up to t, but what's your lower bound? Okay, your lower bound will always be the value that they give you. This is where you go all the way back to the very beginning here. They tell you that at t equals 0, the position is 10. So what you want to do is you actually want to make your lower bound 0 now, okay? But what you have to do is, this integral here is just your accumulation, how much you've moved. But you have to consider where you started. So what you want to do is you want to add on where you started. So in this case, we started at 10. Okay? This right here is your s of t. Okay. So it considers where you started at 10, and also that integration tells you how much this particle moved, okay? So s of 5 is really just you plugging in 5 for t. Now, in the scoring guidelines, they didn't use v of t, they actually used v of x, And that is a good thing to do here. According to the scoring guidelines, it really doesn't matter. The only reason why they're switching the variables is because it's kind of just a placeholder. They don't want to use t twice. Okay? You could use any variable you want, actually. It doesn't have to be x, but most people go to x or t. All right? Here, they really don't ask you to evaluate it. Well, actually, they do. Use this expression to find the position. So this here would just be a simple plug and chug. You would just do 10 plus math 9 from 0 to 5 of y1 dx. And you should get negative 9.207, okay? All right, here's part C. Find all times from 0 to 5 where the particle changes direction. So if a particle is changing directions, this is going to happen right where the derivative is 0. We call that a critical number. But in this case, this is where v of t is going to be 0, because v of t is really just the derivative of position. So what we're going to do is we're going to set that guy equal to 0, okay? Or on a calculator, it's convenient because v of t is already your y1. So what you do is you find your zeros graphically, okay? So here in part C, notice how they give you an interval from 0 to 5. So you definitely want to fix your window so that your x minimum is 0 and your x maximum is 5. Sometimes it's necessary to fix your y min and your y max depending on the graph. But I'm going to go ahead and zoom it into negative 1 and 1 so that we're only looking close to the x-axis, okay? Sometimes we do this because sometimes it's so pixelated that we can't tell if it crosses through multiple times or not. So we might have to zoom in a little bit, okay? So just keep that in mind. So if you do it correctly, if you find your zeros, you should actually find 2 of them. It should be at about 0.5 and 3.3, okay? So remember that when you have a graph, you don't really have to do the sign chart. You're doing the sign chart visually. So you're looking at where velocity is changing signs. So at 0.533, you should notice that velocity is going from negative to positive, or from down below to up above, implying that there is a change in direction, okay? But specifically, this particle went from the left and then decided to turn to the right. Or if we're going vertically, this particle was going down, and then right after 0.53, it was going upwards, okay? But in the problem, they're really just asking for a change in direction. So really, it doesn't matter what the sign changes from and to, because changing directions is just in general. You're just finding a local extremity in general here. But the scoring guidelines kind of just explain it thoroughly here. You could have just said v of t changes signs, implying that the particle changes directions at these 2 times. Okay? Here's the last one. Again, this popped up in, I believe, 2011 and 2012. Is the speed increasing or decreasing at a time? So if you want to know if speed is increasing or decreasing, you have to check 2 things: the velocity and the acceleration at that time. And if they happen to share the same signs, you know the speed will increase. If they share different signs, the speed will decrease, okay? So basically, this v of 4 is your y1 parentheses of 4. You could type this into your home screen. You should get negative 4757. So we know that velocity comes out negative, okay? So here, to find acceleration, you would just go to math 8, d over dx of y1, evaluated at 4. This comes out to something negative, negative 22.295. So notice how they both come out negative, meaning they share the same signs. So you just make a conclusion. Okay? Make sure you explain why. Don't just say the speed is increasing at t equals 4. Make sure you say because v of 4 and a of 4 is less than 0, they share the same signs. Okay?